Now, when you say tree, the way we traverse across the tree has a different logic. Which logic React is taking and why it is taking, that's what we are going to discuss now. Um, so in order, we'll start from the scratch here. So let's say we have an array, and the array traversal is quite easy because it just goes by index one after another. So it goes one after another. But suppose if you want to change this order, we don't want to go by index, we want to go by our own order. What we do is we convert that array of elements to an array of objects, which has information about the next object. So in this way, we can change the order. So linked list is created. So now the order is changed the way we create as a linked list. Now this is good for one-on-one relation, but DOM tree means one-to-many relation. So we need another way of doing it. So we need two values. One is first child and sibling. Let's have this here. Let's say we have a root and we check what's the first child, it's child one, and check again that is there any first child for it, again any first child for it. Like that, we keep traversing in a recursive way and create those linked lists. So in the top, you can see the call stack of all the recursion over here, and this is how the relation is created. So now this is good for us uh, in a one-to-many relation, but think about it. Traversing across a single tree using recursion in a single frame is easy when your DOM structure is small. But if your DOM tree is like huge, you have like lots of elements on the screen, then traversing across to collect all the changes, it's going to put a lot of burden on the JavaScript, and it's not going to execute that single frame in 16.67 milliseconds. So what we can do, we can break down this traversal. Instead of single frame, we can traverse across multiple frames. And how we can achieve that? Um, so to explain the across frame, let me have this here first. So this is one event cycle which I spoke about. In this event cycle, the yellow part is where JavaScript what we do, and the blue part is where browser takes care of does it parts, and the green part is called the idle time. So every browser engine throws an event or dispatch an event at each stage. So the animation callback starts at the beginning stage, and then idle callback is thrown by certain browser. Certain browser doesn't do it. Some people polyfill it to achieve the same result, but this is what happens. So in 16.67 milliseconds, if there is no code, the idle time will be 16 milliseconds here. So those idle time will be taken into consideration now. How? Your JavaScript code will be broken. You broke into multiple frame, like your traversal can be broken, and that can be executed in idle time. So this is what we are going to achieve. So in order to do that, what we'll do is we need to convert the recursive way of traversing into an iteration way of traversing, because when you do an iteration, you have a control to stop that iteration and come back at any time. But in recursion, it's a call stack. The entire call stack has to be cleaned up. So that's what I'm showing here. And how to do that. So if you look at here, in a call stack, we always know who called the previous one. So it's always easy to traverse back. So we need some kind of pointer to traverse back. So that's what we are going to do. In our structure, we are going to create one more object, which is a parent. So that structure is created. So you'll be having a value, parent, first child, and sibling. And then you link. So what will happen is, let's take the root object, and then you call the children's in it. It'll give you 3 children, and then you start linking them. And then as per the rule, you have to check always the grandchild. So you're checking the grandchild, start linking. And when there's no more linking, you keep on building it. And that's what's happening here. So you build those children dynamically.